Welcome to the Codebreakers walkthrough challenges. This will be the walkthrough for Task 2 for those of you that are joining, and for those of you that continue from Task 1, thank you. For this challenge, we are tasked with trying to extract some firmware from a low or hardware device. If we read through the actual description, thanks to your efforts, the USCG discovered an unknown object by triangulating the geo and timestamp entries of the record and correlating entries you provided to the NSA database. Upon discovery, the device appears to be a device with some kind of collection array used for transmitting and receiving. Further visual inspection shows the brains of the device to be reminiscent of a popular hobbyist computer. Common data and visual ports non-responsive. The only exception is a boot prompt output when connected over HDMI. Most interestingly, there is a 40-pin GPIO header with an additional 20-pin header. Many of these physical pins show low voltage activity, which indicate data may be enabled. There may be a way to still interact with the device firmware. So for us, we need to find the correct processor datasheet and then use it in the resources provided to enter which physical pins enable data to and from this device. So here's some notes. The pinout SVG pinout SVG, turn off the dark mode. Don't have to worry about that. Pinout SVG has two voltage types. The gold tan is 3.3 volt and the red is 5 volt. And then the only additional resource we need is the datasheet, or at least relevant information from it. With that, we are given three files: a pinout, a CPU, JPEG, and a boot prompt. Every time they give us files, it's always a good idea to download them because they will always be important. Let's just open them all up. So here appears to be the pinout, CPU, and boot prompt. Just a quick glance at the boot prompt. Device name is empty. Model XYZ1234 probably isn't anything. Firmware version 1.0 doesn't give us anything. Epoch time doesn't give us anything. Initialize collector, loading configuration, starting services, booting up. Collector is online. Alternate function assignment alt is 0. That's the only thing that's really of any note for us, so we're going to keep that in mind. Looking at the other stuff again, pinout. We can see we have several physical pins that represent some GPIO pin connections with some ground voltage, nothing too important, but what we do have here is a picture of the CPU. Looks like we have a Broadcom BCM2837R IFBG CPU. So if we do a quick Google for that, put this guy off to the side. Oh, stuff open from the challenge 1. We go BCM2837R IFBG datasheet, because that's what the challenge had hinted at. Let's see, it's A53 processor, ARM peripherals. You might see references to a Raspberry Pi. That's the reference within the challenge talking about hobbyist computer. It doesn't actually say Raspberry Pi anywhere, so we can't officially say that's what we're using. Just kind of looks similar between this and the CVG pinout. Let's just keep that in mind. You could dive into these, but it might be a little bit tedious to go through this entire 200-page thick doc about talking just low-level stuff. So let's use that other piece of information that we had found earlier, Alt0, and see if we can find anything related to that. So that one shows up still. We got some Raspberry Pi forms. Get a datasheet module here. It looks like it's that same document, if not just a Raspberry Pi 3 version. We have a GPIO sheet, and this kind of looks more of what we're in line with. It looks like it's a version or two behind, but based on the alternate versions, everything probably is close to the same, if not the same and identical to our 7 to our 2835 or 37, whatever version we're on. But we're on Alt0, so we're going to be looking at this column, some other alternate versions if you need those. And what we're interested in particular is the physical pin for the power, physical pin for the ground, and then the physical pin for UART transmit and UART receive. Usually those are identified as TX and DX or RX, so transmit and receive. There's a good chance that GPIO 14 and 15 are what we're looking for on this Alt0 version. And if we look, we can see those two are right here. As for power, this pinout sheet won't give you anything on that, and I'm not quite sure on the best path going forward and trying to find this without a little bit of guessing and checking, as you would probably do with regular hardware. If you knew what the voltage, power, and grounds actually were, you might just tinker with those, and that's what we're going to do. So we're going to start with P1 as the ground. This is the power, so it's ground. P1 as ground and P2 as power. We could think 14, 15 are UARTs now are correct for now, but we're going to assume that we don't want anything to work. So we're going to just say P42 and P42 again. And we're going to use that as our kind of base case. We could actually set everything to P42 to see what our base case looks like. And it's not a bad idea, as these challenges like to give you hints or answers on what you're doing, and if you had an actual physical device, this is the kind of stuff you would see. So none of the pins are correct. You could probably just tell if you were to put power on this pin that nothing would happen. So if we were to try physical pin 2 and physical pin 1, and we can tell they are those numberings, by looking at the physical, or the P1 here and P2 here. So P1, P2, P3, P4, and so on. If you didn't know how to count, that's how these pinouts work. So we try 1 and 2. We can see we have low periodic activity, but no data detected. That may be inclined to show that we are either using the wrong. That usually inclines to show that you're probably using the wrong power pin, in that it's getting the board is getting power, but probably just not enough of what it's expecting. So let's try a different power pin, and let's try P17 this time. We're going to keep the same ground, see if anything changes. P17. Takes a little bit. We can see now that the GPIO headers are powered. Looks like the receive and transmit are correct, which makes sense because we're using P42, but it looks like P1 and P17 are successful for powering this device. So that may have just been that we could probably check again if we want on P39, but maybe any of the 3.3 volts are probably what's powering the GPIO versus the 5 volt red ones. But with that, let's try if we said 14 and 15 based on this data sheet pinout. So 14 for TX, so that'd be 2, 4, 6, 8, 10, 12, 14, 16. So P16 is the physical pin for transmit, and which would then make P18 the physical pin for the receive. And we can find all of that in that data sheet. And like that, task 2 is now complete. And that was just a simple walking through trying to identify data sheets with different GPIO pinouts and trying to identify based on the information we were given. We used the CPU picture to find the correct model, and then the alternate version to find this nifty pinout, which for the GPIO. But yeah, thanks for watching. Hopefully you come to task 3.